Hello. So our good old buddy J Random Troll wishes to run a wire to power his doomsday machine / waffle maker. Everybody's got a combo doomsday machine waffle maker these days. He's going to use his 23 gauge silver wire. 23 gauge, all that tells me is how thick it is. So that means it's got a diameter of 0.5733 millimeters. He's guessing the wire's going to heat up to 80 degrees Celsius. So he needs the resistance of the wire to be no more than 0.31 ohms for his circuit to work properly. So how long can his wire be? And then I give you the values of the resistivity of silver and the temperature coefficient. Well, the equation that involves the length of the wire is the resistance equals the resistivity times the length over the cross-sectional area. So I just do a little bit of algebra magic and solve for L. One other thing that I did here, I took the area and I replaced it with, well, the formula for the area of a circle, because the cross-section of a wire is a circle. All right, I've got almost everything that I need. Looking back here, I know what I want the resistance to be, at least at a maximum, and I know the diameter of it. So first thing I gotta do is I gotta solve for the radius. Well, the radius is just the diameter divided by 2. Oh no, but I'm still in units of millimeters. That's not the base unit of distance. So I gotta convert this to meters. That means I moved the decimal place 3 spots to the left. There are 1,000 millimeters in 1 meter. Woo! There's my radius. So I've gone ahead and I've plugged in my value for my resistance. I've plugged in my value for my radius. But the resistivity here. A tempting thing to do is to plug in this number for the resistivity, except that's the resistivity at 20 degrees Celsius. And he's imagining the wire's going to get to 80 degrees Celsius. 20 and 80 are not the same thing. Oh no. So I got to run to this equation to find what my resistivity will be at 80 degrees. Rho naught, that represents the resistivity at room temperature, which is 20 degrees Celsius. So I can run back here, grab my rho naught value. That's just given. And this is the temperature coefficient. That's denoted by the Greek letter alpha. So I've gone ahead and put those values in. Rho naught is here. Alpha is here. Now delta T. Delta T represents the change from 20 degrees Celsius. If I'm at 80, the change would be 60 degrees Celsius. I also don't want you to get overly confused by the units of alpha. That's degrees Celsius to the negative first power. It's literally just there, so it cancels with the degrees Celsius here. So when I crunch those numbers, I end up with 1.95 times 10 to the negative 8 ohm meters for my resistivity. All I gotta do now is plug that in here. And now I'm all set. My units of ohms will cancel with units of ohms up here. This meter will cancel with 1 of the meters squared. So I'm left entirely in meters at the end, which is great because I'm solving for a length. Let me go ahead and just slap these numbers into a calculator. And I end up with 4.1 meters. So anything more than that, the resistance will be too big. Anything less than that should be totally fine.